Intel's Arc GPUs are the newest competition on the market, and in a world where AMD and NVIDIA are neglecting gaming and consumer users, we went to the factory making Sparkle's Intel Arc gaming GPUs.
Welcome to our contract EMS factory of Sparkle.
This Taiwanese factory makes over 1,000 Intel Arc video cards per day to ship straight to the United States. This is 96 GPUs.
One batch is 560 pieces.
Okay.
Welcome to our SMT line.
Very clean. So this is a solder paste?
Yes, so as you can see, underneath is the PCB.
So this is pick and place, right?
Yes, this is the AOI inspector. Mainly make sure the component is in the right place.
What's the next stage after all this?
Next stage, we cut the PCB. After the SMT process finished in the factory number one, we move the PCBs here to do the deep process.
And our tour guide today is this guy, Lucas, the very same guy who showed us around EVGA's repair center at the end of EVGA's GPU run in our EVGA finale documentary. We've always liked working with him because ultimately he's an enthusiast at heart.
And the oven is fucking cool.
We don't do fake shit.
Okay. I like it. We did something different for this video. Rather than doing voiceover and scripting and me hosting it all alone, we got Lucas to join us. And that is because unlike a lot of the other factories we've toured, Sparkle was willing to just answer literally every question on camera, including stuff about cost. And this is very rare information to get. Do you know what those cost? Like an output, is this part expensive?
Expensier than the display board.
Okay.
It costs $1 per piece.
For HDMI?
Yes.
Wow. Go ahead.
Basically, we're assembling. These two ladies is doing the bracket. That lady over there is thermal paste. Last two lady is the fan screw.
Next is testing. We test every car. So we're now
Right,
in the packing process.
Packing, physical packing, right?
Physical packing.
Now, Lucas used to work for EVGA, which meant he worked with all NVIDIA products, and so we learned a lot about the differences between how Intel versus how NVIDIA treat and handle their board partners. What's like the biggest difference being at Sparkle versus with an established GPU like NVIDIA?
Okay, selling NVIDIA GPU is easy. Intel gives us a more flexibility, so we can literally do whatever we want.
Is it abnormal for the GPU company to give that much flexibility?
I don't think NVIDIA will allow the AIC partner that much room to do whatever they want.
Okay, got it.
Literally, NVIDIA and AMD already give up the segment of this like $100 price car.
Today we're going to tour multiple factories in Taiwan to see how Intel partner Sparkle makes its Arc GPUs. Let's get into the factory. Before that, this video is brought to you by the Fractal Momentum series fans, including the Momentum 12, 12 RGB, 14, and 14 RGB in 120 and 140mm sizes. The Fractal Momentum series fans performed excellently in our review of the Fractal Meshify 3 case previously, but can also be bought separately. The same fans are found in the Epoch case. The RGB options use the softer accented outer ring lighting that we praised in our review of the Meshify 3 case. The fans use high-quality LCP blades for a higher performance operation, and you can learn more at the links in the description below. Lucas, last time I saw you, you were at EVGA. We were in the repair facility.
Yes, yes.
So now you're at Sparkle.
Welcome to our contract EMS factory of Sparkle. We made Intel Arc here, made in Taiwan.
Okay.
So all of these cars shipped to the US, not every place else, just US.
Taiwan factory we're looking at today.
Yes.
Everything you're making here is getting shipped to America. Okay.
Like after production, immediately ship on the ship, go to the US.
Why is that?
Because of Mr. Trump,
the
tariff
situation.
stuff. Yes.
Okay.
So back in March or April, because the tariff just start insane high.
Yeah.
So we moved the production from China partially to Taiwan to manufacture here to avoid the crazy high tariff.
Right.
Yes.
What's the Arc situation like right now? Like, because Arc is still, it's the newest, to the GPU market.
Yeah.
I think it's the most important chance at causing some disruption with AMD and NVIDIA.
Yes.
So, what's it looking like lately? Because you've been working on Sparkle cards since Alchemist.
From Alchemist, yeah. I'll say compared to the Alchemist, Battlemage is a very terrific product, we sold out like every pieces after in manufacture. Intel did a lot of effort to try to avoid the disaster what Alchemist happened.
Right.
I mean software and driver, yes.
Yeah.
Yeah, so I think they did a pretty good job this time in the Battlemage.
If you were to compare it to your old days at EVGA, what's like the biggest difference being at Sparkle with Intel Arc, versus with an established GPU like NVIDIA?
Okay, selling NVIDIA GPU is easy.
Okay.
Every customer knows the NVIDIA, every end user knows the NVIDIA, but Intel Arc as a new discrete GPU brand, sometimes we need to convince, we need to show them more profit to make them even want to try it, to sell it. Yes.
For like the distributors, I guess.
Yes, distributor.
Okay.
Yeah. I'll say Intel gives us a more flexibility, so we can literally do whatever we want, but we need to keep the support fine to the end user. Yeah, it's a promise, it's a branding for sure. We need to do that. But other than that, if we want to do many different cars, like low profile or different output, like the A310, we have 4 HDMI. Yeah, so we can just freely to do that.
Is it abnormal for the GPU company to give that much flexibility?
I don't think NVIDIA will allow the AIC partner that much room to do whatever they want.
Okay, got it.
I think, yes.
Right. For the factories we're looking at today, so we're looking at two.
Yes.
There's SMT, which is where we're starting.
Yes.
So it's service mount technology, and then the second one
is DIP.
DIP.
Yeah, DIP stands for dual inline package. I think it's a bigger component in my memory.
Yeah.
Yes, but in terms of GPU, we have less components to use the DIP process, but we still need it. Like a bigger capacitor and fan connectors, like that.
Okay.
Most of the part, including GPU and VRAM, is all done in the SMT process.
Let's get started.
Of course.
Our first stop was the quality control testing room, where every batch of new components that comes through gets randomly selected and tested to make sure that it's good.
This is the first stop of every component arrive the factory.
Okay.
So when the material arrives, you need to make sure if it's okay. We need to do the quality control.
Right.
So this is the area.
On the suppliers, I guess.
Yes, yes. We got AOI machine here. Automated optical inspection. This is the air seal vacuum machine.
And then what's going on over here?
They're checking the material data sheet. They'll extract 5 of them to do the quality test by measuring the electricity spec.
It's basically a random spot check, I guess.
Yes, random spot check. So after the QC done, you'll move to the storage. Yeah, to keep it there to wait until the production day. Authorized person only.
Okay.
I think we are the authorized person today.
53% humidity in Taiwan is very low.
Very low.
Yeah.
Here's the B580 chipset.
What's the path this goes? It goes from a distributor, so
Distributor.
Intel orders from TSMC.
Yes.
They ship it, I guess, to a distributor.
Yes.
You guys buy from a distributor,
Yes.
and then it comes here.
Yes.
And so that's the
L.
actual, BGA pattern on the bottom, so that'll go onto the PCB. Is the L, do you just customize that because your name is Lucas?
Yes, Lucas Lu.
Right,
So, yeah.
right, that's why, right?
Yeah. So we make dual GPU, LL.
Do they normally ship just like this, and then does it get loaded straight into SMT in these trays?
Yes.
So there's 96 GPUs.
One batch is 560 pieces.
Okay.
Maximum 2 times per day.
Okay,
Yeah,
max 2.
like a 1K, 1.1K.
And that's just
per
for
day.
this factory in Taiwan.
Yes. We do more in a China factory.
Right.
Yes. It's
But
bigger.
that's for the rest of the world, right?
Yes. Yeah, this is
So
the
what is-
B580's PCBs.
Oh, it's B580 PCB.
Yes, yes. Because they're preparing. Tomorrow is SMT process for B580.
Oh, it's just a stack of them.
Yep.
So it's like 5 PCBs in a sealed bag.
Yes.
So these come from your other supplier. So that's, I
course.
think this is something a lot of people don't know is like when a consumer thinks of a
Yes.
factory, I think a
It's-
lot of people are like, oh, the entire product is made in that factory.
No, we ordered every component, maybe from a different supplier. Then we ship it all here to the assemble factory.
You're gonna have PCB supplier, you'll have the
Yeah.
GPU itself,
Yeah.
VRAM.
GPU and VRAM is kits.
Oh, it's a
from
kit.
From Intel, yeah.
Okay.
Intel already bought the VRAM with the GPU.
Okay,
Yeah.
so GPU and VRAM,
Yeah,
PCB, and then I guess
capacitor.
like capacitors,
Yeah.
MLCC,
Yes.
resistor, those are all
Yeah,
different.
power IC, yeah, maybe different. Yeah.
Right.
Sometimes depends on the price. Maybe the second supplier is cheaper. We'll ship to their.
What's
Let's
next?
Go to the SMT line.
SMT.
We got an A310 happening SMT right
Okay.
today.
Why A310? Because I think people would. A310 is like
Yes.
old, right?
Yes.
So why still making A310?
Because what's the competitor have? NVIDIA, like GT 710, GT 1030.
Yeah.
No way. So
Right.
literally, NVIDIA and AMD already give up the segment of this like
Okay.
$100 price car. I think that's where we come in.
Okay.
Yeah, actually the customer react really well. Yes. Welcome to our SMT line.
Very clean. So these are your PCBs.
Yes.
So are these the A310 PCBs?
Yeah, this is the A310 with 4 HDMI.
Okay.
The model,
right
yes.
there.
It's the same PCB with the A380, which comes from 6 gigabit.
Oh,
And the
okay,
A310 is 4 gigabit.
Okay, so you're gonna
you only
populate
use
two.
Yes.
And then GPU here,
Yes.
4 HDMI.
4 HDMI.
So this is what we're gonna see get populated today
No
at
problem.
the factory. So what's the actual model name of the card? A310.
A310 OmniView.
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 So they get loaded in here
Yeah.
on that.
Yes.
There's actually one in there now, it looks like.
Yes.
So that gets fed in. Will automatically get spat through. All right, so there's a card getting fed in right now.
Yes.
So this is solder paste.
Yeah, solar paste. So basically, factory will based on our Gerber file. So as you can see, underneath is the PCB. They'll solar paste and grab it to make sure all the hole fill the paste.
So this is the solder paste.
Yes.
What's the next step?
Next step, we need to make sure the solar paste is in place with the right thickness. So we need a solar paste inspector.
So just spat another board in, and then once it's done with inspection,
That's in the main course. So as you can see, all the component from the smallest to the biggest.
right? So this is pick and place, right?
Yes.
So on one board, what's the typical range of components?
Depends. It's from 1,000 components to around 200 components. For the high-end car, is more components for sure.
1,000 to 2,000.
Yes.
She's swapping the ammunition.
Yes.
Okay.
Playing the movie.
Okay, cool. So that one's depleted, so I guess it's going down to inventory to
Yes.
get more. So we've got connectors here.
Yes.
That looks like BIOS. Is that BIOS? Just BIOS, not. BIOS.
Yes.
Okay. Was BIOS already flashed?
No.
No.
No flash in the testing progress. In
Okay.
the factory number 2. So after all the components, MLCC is mounted, but it's still shaking, right? It's still paste.
Yeah.
So we go to a reflow oven.
Okay.
So this oven fill with the nitrogen.
Yeah.
Minimize the oxygen.
Okay.
Yeah.
I guess these are temperatures. So it goes from 90 to 260.
260, yes. Basically, heat up the solar paste and make it solid
Okay.
to mount the components.
So it's solidifying the components in the paste.
Yes.
And after it comes out of the oven, where is it getting fed into next?
This is the AOI inspector. Mainly make sure the component is in the right place. 5 different angles of light and
Yeah.
the camera to inspect.
Is this pass fail?
Yes.
Oh, okay.
Fail.
So 0.3% failed.
Yeah.
Any idea what the typical failure is? Like
Computer thing is not fit the standard, but sometimes it can get wrong.
false positive?
False positive, yes.
Okay.
So he will manually check by the picture to see if it's truly failed.
Okay.
Yes. Basically, computer is telling us a little bit too much paste on it, but
Okay.
it doesn't concern anything.
Oh, so it causes a resistance problem.
Yeah. The computer wants a consistency of
Yeah.
every car. So if this car has a little bit more paste, he will just brought it out and say maybe it's wrong. If it's not
fit the standard, you'll go to the manual check-in. 不良.
Okay.
No good.
Yeah. Okay.
Yeah.
So we can actually catch this one that we just saw. Can that be my review sample?
Sure. Yeah, sure.
Okay, so on her screen in front of her, there's the actual AOI failure.
Yeah, AOI, yes. Actually, it's a picture from the previous stop. So after the lady is checking, if it's false positive, it'll just go back to the topper tray.
Okay.
It's a good one, so you can move to the next stop.
So this one's a false positive.
Yeah. If it's a real
Defect.
negative product, it'll go underneath. So basically, you'll collect and manual with the machine to adjust. Maybe it's the component is slightly different angle, bad angle. You'll just heat it up and move it back. It's okay. Yeah, like that.
What's like the rate of false positives versus real defects?
50-50.
Okay.
50 false positive, 50 real defect.
And then the actual machine rejection rate, AOI, was like 0.3% or 0.2.
Yes,
Yeah.
0.2.
And then of those, so half are false positives.
Yes.
So it's kind of like overly aggressive on identifying.
Yeah, we want to make sure every car is good.
Right.
Yeah.
No, that's probably a good
We
thing.
don't need any reds to coming out.
Right.
Is that the correct
Sure.
description?
Yeah, that works. I think that works. I think everyone will understand. So this is what just got done. So we've got MLCCs, BIOS, and that's about it right now.
So,
Looks good. So now it needs to go back in for this side.
yes. So basically, it's the same process,
Yeah.
but it's upper side.
So this has the ones with the populated back.
Yeah.
So the back is done here.
Back is done. So
And-
shoot all the way from the front to the end again.
Do you know how many boards you're running through this line?
Today,
Yeah.
1,120 pieces.
Okay.
Yeah.
Of A3.
A310 OmniView. Yeah.
A310 OmniView. Okay. What's the first stage on this side?
It's a solar paste. That's a
Paste
standstill.
again, yeah.
Paste again, yes.
So
On the
same
front,
pin,
same
different
thing.
side. Yeah.
Yes.
This is interesting. So we've got the actual stats here. This has done 124 boards, I guess, so
Yes.
far for this cycle
24
Yeah.
second
per board. Is there any additional complication when one side already has stuff on it?
Basically, no.
Okay.
So if we ever happen a problem, it's the back side of the component is too heavy. It might drop in the oven, right?
Okay.
So if in that case, a factory guy will extra glue it, put a little bit glue on it.
Okay.
But in the GPU production, no, you don't
Okay.
need that. So
Got it.
It's the same.
So it's for the only time that would happen is for other components, like
Yeah,
other
other products maybe. Yeah.
Not really your problem.
Yeah.
Okay.
The
Cool.
GPU is fine.
All right. So we got board coming across.
Yeah.
Now it's back into pick and place.
Yes.
So this is still
MLCC.
small stuff. MLCCs, resistors, caps. You've got big inductors. There are small inductors back there. More big inductors. And then HDMI.
HDMI.
I guess you use a lot of these for this product.
Yes, 4 HDMI output.
Do you know what those cost? Like an output is this part expensive?
Expensive than the DisplayPort.
Okay.
It costs $1 per piece.
For HDMI?
Yes.
Wow. Okay.
Most of it is the authorization fee to
Oh.
HDMI company.
Licensing.
License, yes.
Okay.
So it's expensive.
So if you have a board with 4 of them, then that's like $4.
Yes,
Cost.
$4 cost.
Crazy. So now it's got pretty much everything on it, and then
Yeah.
what's happening here?
It's reflow oven again. It's
Okay.
Heat up.
270 here at the very
270,
end.
70, yeah. I guess GPU need extra 10 degrees to mount it up.
Yeah, it's crazy it can take that much heat, but I guess it's such a short period of time.
Yeah. AOI again.
AOI, okay. A little bit higher defect rate on this side than the other side.
Yeah.
But I guess that's the whole point, is catching them.
Yes.
So then she's looking over the ones that were
Yes.
defective.
As you can see, there's all false positive. There's no backup.
Right, right.
That's all good car.
What's the next stage after all this?
Next stage, we cut the PCB.
Okay,
Yeah.
let's take a
See
look.
the cutting.
So walk us through what he's doing here, Lucas.
Okay, so as you can see, there's a 2 pad with the outline there. Put the PCB from the SMT line, put it on, and basically the machine will cut it on based on the outline.
Okay.
Yeah. It's a small drill.
Oh, it's a drill. Okay.
It's drill. It's grind it out.
Okay, so then after this one comes out, they're gonna have all 4.
Yeah.
And then it goes over to dust, right? So we'll go over this way.
Basically, it's a giant air blower to clean out the dust while cutting. There you go.
Cool.
Then we'll pack with the bag and
Right.
ship to the factory number 2 and go through a dip process.
So what's the fastest and slowest part of this process?
Let's say the slowest process, the SMT process. They're capped in 1.5K to 2K per day.
Okay.
Yeah, that's the bottleneck.
Got
right
it.
there. And other than that, it's faster than this process.
Okay.
So that's the bottleneck.
Is there anything like they're working on improving right now?
I think the warehouse.
Okay.
Right now is, although it is a computer assisting, but it still rely on manual pulling out the components. They are heading to the automatic warehouse.
Right.
Yeah, heading towards that way.
More automation.
Yes.
Let's go over to part 2.
Let's go. So this is the dip process, right? After the SMT process finished in the factory number 1, we move the PCBs here to do the dip process. They are manually mounting the capacitor. If too many components, we will mount by
Yeah, I see the hopper here with connectors.
Yes.
And then these just load with the reels of components.
Yes.
So they have PCBs here, I guess.
Yes.
What PCB is this? Do you
This
know?
is the A380
Okay.
ELF.
So they're pulling the A380 boards out of here. I guess, did these come from the first factory?
Yes.
Okay.
After the SMT process, we ship just like 2 minutes away.
Yeah.
Yeah.
So they just truck them over here.
Yes.
And then they're manually pulling the PCB and putting it in
Yes.
like a jig, I guess, to hold it. Like this
Yes.
just holds it?
Yes. Hold it.
Okay.
Yes. So manually put the component capacitor.
So does each person do a different part?
Yes. They will have their own area.
What's next over here?
Here is our wave soldering. Basically, there's a whole pot of melting solder.
So is this the temperature along the oven, I guess? Or
Yes.
along the molten, okay.
So it will go through the flux
Yeah.
first, then
Yeah.
you go to a soldering paste. So you need to preheat a little bit.
Okay, so it's 219, 280, 350 C.
Yeah.
It's very hot.
Yes.
Oh wow, cool.
Oh, here.
Okay. Oh yeah. 可以打开吗？ Cool.
And the oven is fucking cool.
We don't do fake shit.
I like it. I like it. Heats up here, and then
Just keep it warm.
right.
Yeah. Control the temperature in the certain.
What are the tubes for here? These black tubes
这个管子是
for fumes.
fulfill the nitrogen.
Okay. So this is the actual
Yeah.
wave soldering process.
Yes.
Can you explain to me like what we're seeing here now that we're looking at it?
Okay, so basically we create a wave to the solder paste. So when the car's going up and just a little bit tip of the wave,
Right.
tip of the solder paste, it will get it right on the component.
Flow the bottom.
Designate component.
Right.
Yeah, because we have the plate right down there, right?
So is the nitrogen, you said the nitrogen filling is new?
Yes.
Okay. Because I've been to wave soldering stuff in the past,
Yes.
and it was all just open.
Just open.
Yeah.
Then you probably get oxidized in the inside.
And the
of it.
connectors.
Yeah.
Okay. All right, so we've got the float boards come out here.
Yes.
walk me through what's happening at this point, because
Okay.
I saw one return this way too.
Yes. So the pad is helping through the deep process, right?
Yeah.
So now it's complete and it's cool down.
So the workers here place the board down here
Yes.
and then return it. So we've got
Yeah.
this double layer conveyor belt.
Yes. Removing the gold pin,
Okay.
PCIe pins cover,
Yeah.
because during the process it might hurt the
Pins.
the pins. Yes. And most
Worker-
ladies are doing the same thing. Remove the pins cover and try to clean up the soldering.
Okay.
Because this is not manual, it's going to the factory line.
Right.
Might a little bit dirty.
So yeah, we've got
On
the
the edge.
Kapton tape covering the PCIe slot,
Yes.
the pins, and then the manual soldering work here.
Yes. If a little bit short circuit, you will adjust it manually.
So if anything got shorted,
Yes.
they're reworking it.
They'll
Okay.
rework a little bit. Yes.
Got it. Oh, I guess up here you've got the SOP too. It
Yes.
looks like, yeah.
Every stage.
Okay. Cool. So this is their instructions.
Working guiding book.
Got it. That's cool.
Working instruction. Yes.
Yeah, pretty cool. Okay.
Yes.
So using a multimeter here.
Yes.
Okay. So it looks like check-in. Oh yeah, the leg of the inductor.
Yes.
So if there's a problem, if there's like a short, what happens?
Also, if the number is over the standard, we will collect it to the troubleshooting another depot, another
Okay.
area.
Go ahead.
Basically, we're assembling. These two lady is doing the bracket. That lady over there is thermal paste,
Okay.
and the last two lady is the fan screw.
Okay.
Yes.
So this is the PCIe slot.
Yes.
Just got a bin of screws here. Auto screwdriver.
Yes.
Yeah.
We got an SOP right over there as well.
So is the paste fed through this machine?
还是它打
Oh,
进
it's
去
in the end. Okay.
对
In the syringe.
Yeah, this is just the air pressure.
And then the air pushes it through.
Yeah. It will calculate the very precise amount of the paste for
Okay.
every car. Yeah.
What's like the max capacity of this plant? Do you know?
Between 20K to 22K
Per month.
Per month, yes. But Sparkle only occupy like 5 to 8K per month.
Okay.
Yes. We're trying to reach their max capacity.
Right.
Yeah.
And then I guess they have other customers for the rest or something.
Yes.
What's next?
Next is testing. We test every car through a program that Intel provides.
Yeah, I was gonna say I don't recognize this. This I do. That's just Time Spy.
Yes.
So that's just 3D Mark Time Spy.
Yes.
This is some Intel thing.
I think so.
It's
yeah.
OpenGL, I guess. So it cycles through a couple programs. Do you know how many
Yes.
it does?
No, but I do know it costs about 10 minutes.
10 minutes.
Yes.
Okay. What kinds of things is this testing?
Time Spy and the old software you just
Yeah.
saw, and he'll try out the PCIe Express speed, like by 1, by 2, by 8, by 16, and,
Okay.
and get reverse. And the fan speed, 30%, 50%, 80%, 100%.
Okay.
GPU maximum clock and the memory maximum clock.
Cool. Okay.
Yes.
Packing, physical packing, right?
Physical packing. So they are now packing our B570.
Okay.
Yeah, Guardian. Dual fan version.
This is a model that's been out for a little while, right? They're putting the plastic protectors in.
Yes. Remove the screw, lost your
Okay.
warranty.
Tamper seal.
Yes.
All right, so you get the protective stuff for the I/O, the sticker, and then what's it looks like
This
the
is,
anti-static bag.
Yes.
What happens when they scan it? Does it track the history
Yes.
for the card? Okay.
It will produce a document to let U.S. government know it's made in Taiwan.
Okay.
It's end up here and packed, shipped to the U.S.
Right.
Yeah.
So this completes packing, I guess.
Yes.
So it gets one more scan
Yes.
and then goes in a carton.
yes.
And this is
Basically, scan the same thing. One is on the car, one is on the box.
so this is almost 20 kilograms of video cards.
20.
Yeah, we're just 18.7 kilos of video cards. It's like drugs at this point.
Currently, B580, B570 is shipped by air.
Okay. Why by air? What makes you decide air versus?
We want to fulfill the U.S. market as soon as possible, and
Okay.
it's the MSRP is high enough to cover the shipping cost, air shipping cost.
What's the difference, like air versus ocean freight? You know, how much more do you really pay?
B580 Titan,
The big one.
the big one, $20, $20 US.
Air freight?
Air freight
Per
from,
unit?
Per unit.
Fuck.
From
All
here
right.
to
Yeah.
If it's sea shipping, it's like $5 or $7.
Okay.
So
wow.
different.
All right.
So we ship all sea shipping, all the A380, A310 is cost effective.
Because the MSRP is lower.
It's lower, yeah.
Okay.
And it's mass production.
Yeah.
And it's so for a while we can supply pretty well. So we can in the long term we arrange the sea shipping.
Okay.
Yeah.
So, when do you decide to switch from like ocean versus air? You know, is it just how much you? Because I guess if you already have a bunch of supply in the channel in the U.S., do you do ocean freight? Like
Yeah,
if there's
I do.
already supply.
Yeah, I'll do ocean.
Okay.
Yeah. It's all about the selling speed, right?
Right.
We don't want out of stock. In channel business, we never want out of stock. So time is the key.
Okay.
I sell more one piece, that means my competitors sell less.
Right.
Yes.
Right.
So speed is the key. We want to fulfill it quick. We do the air shipping.
Right.
Yeah, so
Right.
yeah, as long as it's not out of stock, I can do my sea shipping. Yeah.
What's
by
the
my wheel.
time difference? Shipping speed difference?
Air shipping 2 days, 3 days. Sea shipping 1 month.
Yeah.
Yeah.
Okay.
So it's a long-term game.
Yeah. So is that all the steps for this factory?
Yeah. Yeah. In the second factory.
Yeah. That concludes our tour of the Sparkle factory where the Intel Arc GPUs are made. We've seen a lot of video cards get made over the years, and they follow really similar and often the exact same steps as you're seeing here, but the differences tend to be in things like the speed, how long they spend on each step, the temperatures of the ovens, the quality control steps, or when they flash the BIOS. Some do it before, some do it after the process, the testing duration, things like that. In this video though, the thing we learned the most about was how Intel interfaces with its partners and some of the cost metrics that we didn't have before. It's also just cool that the guy giving this tour used to work at the largest and most premier NVIDIA partner, so he's got a lot of perspective. He's also not afraid to share it. If you like this kind of tour, we self-fund our travel for all of these, so that is made possible by your support on store.gamersnexus.net. The companies we are touring do not have any financial involvement, even down to the booking and the travel for these tours. We fully pay for them ourselves and arrange them. So with your support, we can continue doing that. Thanks for your help, and subscribe for more.